So I'm Doug Song. I'm CEO and co-founder of Duo Security. Briefly, a little bit about us and where you are. So you're here at the headquarters of Duo Security, which is based here in Ann Arbor. We're proudly a Michigan-based company. Woo! Yeah! All right, yeah. And, a weekend ago, we sent a spacecraft up. This is actually a photo from our inaugural launch of our high-altitude weather balloon that we sent to, near space. But kind of a marketing thing that we were doing, a fun stunt, right, to do during DEF CON, the big hacker conference that happens every summer in Las Vegas. And so, yeah, out in the desert of Las Vegas, we were sending, sorry, I lost something. Spacecraft up there. But we do other things than that. So, the company, a little bit about us, we're a company that's very fast growing. Some people have said we're the fastest growing tech company in the Midwest. But this will be actually, we've had the last 3 years of tripling revenue every year and doubling the team every year. So it's been a very fast ramp. We have offices in Ann Arbor, but also in San Francisco, in Austin, Texas, and in London. And what we do here is we protect organizations against breach. So we secure users, their devices, and their access to corporate services. If you know anybody that has such problems, point them to us at duo.com. Quick picture of what that looks like. So we are not only one of the fastest growing tech companies in Michigan or the Midwest, we're one of the fastest growing tech companies, period. And so we sort of map against a whole bunch of the companies that you might have heard of, like Slack. And we're hiring. And so that's the one point I want to make. Across the board, actually, it's not just a software engineer and and engineering manager positions. We have a whole bunch. Actually, Courtney, do you want to mention what positions we have currently open?
Hi, everyone. I'm Courtney Paxson. As Doug mentioned, I'm a recruiter here, and I work with the engineering and product team. So thank you. Welcome. So these are kind of our top positions. If we're going to focus on engineering, we do have some Windows-specific roles that we are recruiting for, senior software engineers. We actually have a Windows manager role available as well. And we're also looking for some QA folks, QA director, senior QA analysts. And then, do you want me to touch on all these other ones?
We can probably pass.
Okay, all right, thanks. Welcome, everyone.
All right, thank you. Yeah, so we are growing. If you check out duo.com jobs, you'll find more about it. And we are a big team now, about 300 people, proudly, again, mostly centered here, but also elsewhere. So that's who we are. But I wanted to introduce our speaker for tonight, who is an old friend from the University of Michigan, Jennifer Marsman, who is principal developer evangelist at Microsoft. And her role is really to educate developers on all of Microsoft's awesome technologies, like tonight. Prior to this, she was a developer in the Natural Interactive Services division with 2 patents for her work in search and data mining. But was really excited to see this year was her recognition as one of the top 100 most influential individuals in artificial intelligence and machine learning by Analytica. So that's pretty awesome. She's also been featured, I don't know if you read this article in Bloomberg that was about Azure machine learning, and it was actually mostly about Jennifer and a little bit about Satya, the CEO, and I thought that was pretty amazing. She's also really active in the community, so those of you who have not seen her speak at a local community event like this one, you probably will at some point if you haven't already, but she's beyond sort of the evangelist role. She's been involved in Give Camp and a bunch of the charities, organizing the first one here in Michigan, and a bunch of the user groups around the region. She's a proud Wolverine with degrees in computer engineering, a master's degree in CS and engineering, and graduate work that really did specialize in artificial intelligence, computational theory, and just generally is an amazing technologist and speaker and advocate for all these new things that are possible via the cloud. Like those of you who aren't familiar with security and big data and machine learning, there's a whole sort of confluence of this stuff happening today. And we are very excited to be able to support a talk in this area, given that so many of them that we do here are about strictly technology, or strictly security. But if you check out Duo Tech Talks on the web, you'll see the whole calendar of events. We do them monthly. They're always here in this office. Well, one of our offices here, or Austin, or in San Francisco. So we hope you join us again for the next one. But without further ado, I want to introduce Jennifer Marsman.
Thank you. I'm gonna turn this off.
Sorry, you got
Yeah, I have this, but here, you can turn it off and put it right there. All right, awesome. Awesome. Thank you, guys. And thank you, Doug, for the kind intro. It's really funny. I've known Doug since we went to college together, and it's funny because if you don't know, this guy is a legend as well. So anyone who doesn't know Doug well, oh my gosh, he has come a long way as well since he was a crazy hacker in college. I have stories, man. I have stories. So welcome. I hope tonight to really focus on Azure machine learning. So what I'm going to try to do by talking really, really fast is fit into an hour kind of the whole process of how do we get data into Azure machine learning, and then how do we build a model, train a model, test a model, and then how do you deploy that model and write code to actually call the model. So we're going to kind of try to go through the whole life cycle end to end so that you can kind of walk away feeling like you understand, okay, here's the basis to get started. And then I'll make sure to leave you with some resources as well. And then we're going to use kind of a fun scenario that I really like is we're going to try to predict who would survive the Titanic, given a set of demographic information about the Titanic, so people's genders and their ages and what class of ticket they had. Can we predict whether or not they would have survived or tragically perished on the Titanic? It's a ship. It sank. Spoiler alert. All right, just so we're all on the same page here. Sorry. Okay. So there was a movie. So I've heard there's a movie that may come into play. All right, so I do have a blog. I'm on Twitter, all that kind of good stuff. So if you do have any questions, feel free to reach out afterwards. I'm happy to connect and such. And then I should also mention, my teammates and I also, this year, we're kind of starting this new program where sometimes we work with people and write prototype code with them, for them, in certain scenarios, very, boxed. But if you guys think of opportunities where you might be using machine learning in your jobs and might want a little bit of prototype code to kind of get you started, or think about how to work with your data, feel free to ping me about that offline too, and I can tell you, we can see if it would fit within the constraints of that program. All right, and then you also get PR with Microsoft potentially out of that program too, because if it's a success story on our platform, then which is really nice for startups, especially if you're a startup, and you can, then Microsoft's marketing engine is pretty incredible. All right, so here we go. So let me start by just giving you some background on machine learning. So I'm going to start by specifically focusing on the subset of machine learning called supervised machine learning, all right? And with supervised machine learning, what you can do is you have some subset of data, and I want to make a prediction about the data. So I need to start with a labeled data set. So for example, if I wanted to predict the price of a home, I would need some data like this where I have a whole bunch of what we call features or things that may influence the price of a home. So things like square footage tends to be very relevant, number of bedrooms, number of bathrooms, maybe how long it's been since the kitchen was last remodeled, whatever other kinds of data like that. Zip code, as anyone who lives in Detroit knows, there's kind of like San Francisco. If you live in San Francisco and if you live in Detroit, you're going to be paying very different amounts for the same amount of square footage. So things like location, and this kind of San Francisco, Detroit, and then like normal in between, kind of the whole range. So you take kind of those types of things, and then those things all may influence the price. And so the price would be my label in this labeled data set. So then all supervised machine learning is doing, is using crazy beautiful math to find the correlations between these features and that label, okay? So, and then the kind of crazy beautiful math it uses just depends on what algorithms you're using. So you guys may have heard things like, Bayesian networks versus support vector machines versus, you guys may have been hearing, neural nets. Even a simple regression type calculation would work for like that. So just things like that, or maybe even if you remember your AX plus BY plus CZ from back in high school math, it's just applying different weights to these things and then adding them together could potentially work. So things like that, it's just different types of math to find those correlations. But essentially what it can do is then figure out what is the weight, what is the relevance of each of these things in a couple different ways. Decision trees as well are pretty fun. All right, so that's how supervised machine learning works. Now, so that's kind of just in general, and then let me tell you about 4 categories of machine learning as well. These are the 4 categories that are currently supported in Azure Machine Learning. Classification, regression, and anomaly detection are all examples of supervised machine learning algorithms. And then we also have unsupervised learning as well, clustering. So let me start with clustering, actually. So with clustering, that's an unsupervised machine learning algorithm. So you don't need to provide a labeled data set to start with that. But essentially what you can do with a clustering algorithm is group like things together. And then you have to figure out, what does like look like, and then use things like Euclidean distance and such to find out what types of things are close to each other. So clustering can come in handy for things like trying to group similar genres of movies together, for example, to do a recommendation engine, perhaps. So that's kind of some of the beauty of clustering. And it's also really great when someone hands you a data set and says, here, go do something interesting with this, and you're just trying to peruse and figure out what kind of data you even have. Sometimes just running some clustering things and seeing how things sort and lay out can be insightful. All right, then the other two categories or the other three categories are all examples of supervised learning. And so these are just the categories of algorithms in Azure Machine Learning 2, I should point out. We actually have 25 different algorithms that all fit within these 4 categories. So let me start at the big top, classification. So with classification, what you're trying to do is group things into one of several discrete categories of things, right? So is this woman going to develop breast cancer? Yes or no? Is my husband telling me the truth, or is he lying? Truth or lie? That's another talk that's coming up, but I have a whole talk on that as well. The other, who is going to win this game, Michigan or Michigan State? So those kind of things where you have two or more discrete categories. The answer, of course, is always Michigan. Decision tree pointing right to Michigan. But there's different things, it doesn't have to be just 2, so that's a binary classification, but there could be more than 2. You could be choosing between 3 or 4 types of things as well. So that's classification. Regression is very, very similar, only with regression, what you're doing is trying to predict a value on a continuum, right? So it's a number. So this example right here is actually a regression problem, because in my sample data here, this data that I give to train the model, I may give it all this data, and it sees all of these prices, and of course I would give it way more data than this. I didn't say this, but let me be really clear. You actually need a lot of data that covers kind of the majority of cases to make this work properly so that it can learn from the breadth of knowledge that it has. And then you also need, hopefully, more than 2 features, but in this case of buying a house, I think it's probably dependent on more than 2 things. You may be able to do something with just this, but typically the more features could potentially help. That's not always the case, though. So in this case, in this scenario with regression, it's a value on a continuum, right? So it could predict, though, something different, like maybe this given house is 450 grand, even though I never gave it that value as an input, right? With classification, it only has those discrete categories that you've given it are the only things that will predict at the end of the day. With this, since it's a number, a value on a continuum, it can extrapolate between those values, okay, with regression. And then when we do build one of these models, we give it all this data to train with, and then from that it can figure out those correlations, and then you can give it new data. So in this case, I would give it square footage and the zip code and say, okay, based on this data now, tell me what the price would be, and it would be able to predict that based on what it's learned from this training data. Okay? Awesome. All right. So that's classification, regression, so the buying the home is an example of that. And then finally, anomaly detection is kind of an interesting case. Anomaly detection is an example of supervised learning that's really useful when you have a highly disparate data set. So let's take the case of credit card fraud detection. All right, so if I'm a credit card company, hopefully, my database is going to be a whole bunch of valid transactions, right? And then the number of fraudulent transactions is going to be only a very small amount, and then actually the number of known fraudulent transactions is going to be even smaller than that, right? So just trying to train and build a classifier when you have a ton of data on one side and not so much on the other side can be really challenging. So one of the things that can account for that is these anomaly detection algorithms, where they basically train on kind of the known good, and then they can find things that are outside of the values of normal. So we actually have 2 anomaly detection algorithms that are included inside of Azure ML. All right. So those are kind of the overview, and those 4 categories, and then it's actually 25 different machine learning algorithms. The majority of them are regression and classification algorithms. And then the way Azure Machine Learning works, you're going to see it in all its glory in just 1 second when we jump over to the demo. But in that, the way it works is it's just a browser-based thing, so you don't need to download or install anything. You can jump on a browser and get it going. And then it's a nice kind of graphical user interface, so you have modules for importing data, for cleaning data, doing a lot of the things you might want to do, deleting duplicate rows, removing things with missing data, a lot of different things that you can do there, and I'll show you some examples of that in a bit. And then you just wire up a quick data flow of, okay, let me do this data cleaning, and then let me split my data set and do all the other things you typically want to do. And you can build experiments to train and test these models. And then it is literally a button press, deploy. And it'll expose that as a REST endpoint, and then you can make calls to it. And it gives you a security key so that only people with that key can call. So it's a very, very simple deployment model, which is really one of the most beautiful parts of it, I think. So, because typically the deployment can be a pain in other machine learning that I've found. Okay, so here's one example of a template you could use for supervised machine learning. This is a very simple example. We also do support cross-validation K-folds for those of you guys with machine learning backgrounds. We have a lot of other things we do besides this, but here's kind of one simple example of how you could potentially do supervised learning. And we'd start with the data set. I'll show you how to get the data set in a second. Then you can run several data cleaning modules, however many you want. And then with supervised machine learning, we typically split our data. And the reason for that is we have this big data set, right? So imagine we're back here on this guy, and we have our data set. And this is a nice labeled data set that we have, where we know for this square footage and this zip code, this is my price. So why we data is if I had trained my model with all of this data, and then I wanted to see how well it performed, and I asked it, okay, how much is a house with 2,000 square feet in the zip code 48075 going to cost? Of course it's going to give me the right answer because I just trained it on that information. But really, the measure of how well your model performs is based on, how well can it do with data it's never seen before. So that's why when we have a nice data set like this, you typically hold back a subsection of it, train the model with the majority of the data, but then hold back a little bit, and then to test, I then throw that data that I've held back at it, see how well it performs, and then I can compare it to those known right answers that I've held back. All right? So that's why we typically split when we're doing machine learning. And there's a lot of different ways to do this. There's what I mentioned before, this K-folds method is you divide all your data up into, let's say K is 10, divide all your data up into 10 chunks and build one model with 9/10 of the data and hold back the one, and then use a different 9 and build and then test with the one over and over again. So we have support for that as well and other ways as well. But in this case, let's say we're just doing a simple 70-30 split, okay? So we take split, and let's take 70% of that data and use that to train my model. So then I just feed in some algorithm, and there's a whole bunch of initial parameters and stuff you can tweak to get higher accuracy there. And I take that 70% of data and build a model based on that. And then I have a trained model that comes out of there, and then I can send in the test data to score my model. And so that will take that trained model that I have and then throw the test data, all of those features at it, and look for the prediction. And then it will compare against the known right answers that's held back from that test data and see how well it actually performed. And then you can do the whole same thing over here on the other side and then compare those two models against each other. So I might build the same thing right here, only I use a different algorithm to compare two algorithms to see which one is performing better on my data set. Or I might use once I've settled on an algorithm, I might tweak the initial parameters and see which one is working better. So you can kind of then almost use it as like a rapid application development type tool for machine learning, where you can just tweak, and really easily get some good results. Okay? And then evaluate model allows you to compare, and I'll show you what that looks like too in just a second. All right, so the next question you might ask is, okay, Jen, that might make sense, but now there's an algorithm, and you told me there's 25 different algorithms in Azure Machine Learning, and I have to feed in an algorithm, and how the heck am I supposed to know which algorithm to feed in? Enter the Azure Machine Learning cheat sheet. Cheat sheet, cheat sheet, cheat sheet. So this is a really, really great resource that this wonderful guy, Brandon, on the Azure Machine Learning team, he's on their data science team, put together. And it's a great resource where you can essentially start right here and then figure out what it is that you want to do. So you want to discover structure in your data and cluster it together. You want to find unusual data points. You want to predict values, or you want to predict categories. And if we were hypothetically about to predict who was going to survive and who was going to die on the Titanic, what would that be? Discovering structure, finding unusual data points, predicting values, or predicting categories? Right, predicting categories, yes. And are we trying to predict three or more categories, or are we trying to predict 2 categories? 2. Everyone was either alive or dead. There were no zombies on the Titanic. So 2 classifiers, so we'd go here, and then it gives you a really nice declarative model of here's where each of these different algorithms shine. For example, SVMs, a support vector machine, those are really good when you have a ton of features. They can break up that space really, really well. There's other ones that are really good for linear data. There are some that are good for accuracy, but a boosted decision tree is going to take up a lot of memory, so you got to keep that in mind. So a lot of really good things, but it kind of tells you declaratively where the different strengths are, so it allows you to make a good choice. So if you are curious for more information and would like to download that, it also makes a really cool thing to hang on your office wall. You can download it at aka.ms/WAC Azure Machine Learning Cheat Sheet. And then I threw in another resource in there as well. I put together a blog post on getting started with Azure Machine Learning. It's really was written for a student audience, so the actual title is How to Win a Hackathon with Azure Machine Learning. But just ignore the spin in the first paragraph, and then the rest of it is like how to get started with Azure Machine Learning. But it's got a lot of good stuff in it. It's got where to find cool data sets to play with. So if you just kind of want to kick the tires with machine learning, like where do I find like cool data sets to play with, it gives you a link to this walkthrough tutorial that's really good if you want to try the whole end-to-end process. And it gives you a lot of other kind of cool things. A link to the cheat sheet is on there too. So that's aka.ms/WAC HackML if you're interested in that. Okay, waiting for the cameras to go down. Okay, good. The next thing is how do I get data in? There's actually 4 different ways to get data into Azure Machine Learning. And if you forget later and you want to know how, I have both a blog post and a video of how to do it at that link. So you can choose whatever medium you prefer. But essentially, there's sample data in there. Actually, I'm just going to jump over and show you. We'll just go into the tool and show you in just 1 second. All right, but there's the link. You'll have that resource. I gave the slides to the Duo guys, so you can grab them from there later, too, if you want. And let's just go ahead and demo. Yeah. All right, so the rest of this is all going to be demo. All right. Does everyone feel like the stage has been set well enough? Are we good? OK, cool. So what I'm going to do is let me start by showing you those 4 different ways to get data in, and then we're going to solve the Titanic problem. We're going to figure out, we're going to predict this. So what I did is I have Azure Machine Learning open. It's studio.azureml.net. There's actually a free tier too. So that you can get even without having an Azure subscription. So if you want to just go and kick the tires and try it out, great. If you're a startup, you may be eligible for BizSpark, which has Azure credit, great. Students have some different offers that are available as well. If you have MSDN through your company, there's Azure Hours there. So there's lots of ways of getting some Azure goodness. So I'm just doing a new experiment. I'm actually going to do a blank experiment, but let me just show you all of the awesome that's here. They actually have some really neat samples. So you can see stuff like, so these are all, so being able to convert handwritten digits into the text understanding, like what, semantically what letters were done. There's a really great anomaly detection one. I've used that one before to build some stuff. Different credit risk things, direct marketing, a lot of binary things. This Twitter sentiment analysis one is useful because just about everybody can benefit from seeing what people are saying about their company and that sort of thing. The flight delay prediction one is kind of fun just to play with that data. There's like some neat clustering examples, like trying to define, what color would this map to? So different pixels, this shade would map to yellow, and this one would map to red, those kind of things. And then similar companies based on Wikipedia data. So looking at the text in a Wikipedia article, Apple has the word computer in it a lot. Microsoft has the word computer in it a lot. They must be similar companies, things like that. So there's all kinds of really just neat stuff in here. So peruse these at your leisure if you want, because there's all kinds of stuff. Predictive maintenance, which is really useful for if you're trying to predict equipment failure or anything like that. Recommendation engines, there's a whole bunch of recommendation engines in here for recommending movies and recommending restaurants based on Yelp data. So all kinds of good stuff in here. So go and check these out later because they're awesome. Okay, but I'm just going to start with a blank experiment because I want to show you completely from scratch. Here's how we do this thing. And let me start by showing you the ways to get data into Azure. So first of all, I mentioned that there's sample data. So if you go under saved data sets, the first time you come here, you will not have the my data sets because that won't exist yet, but you will have all of these samples. So there's all of this airport codes, the bike rental data. So this is a very popular data set from the University of California, Irvine, which is really fun to predict. Kind of a neat thing because everyone in California is very healthy and drives their bikes. But if you have situations where everybody lives in the suburbs and is driving into the city, or vice versa, you got to predict where should those bikes be at any given time. So imagine it's a nice day, everyone rides their bikes into the city, but then it rains, and so everybody takes public transportation home. They take like the subway or whatever, the BART home. In that case, then what do you do? How do you get? Need to figure out, okay, where those bikes need to be the next morning, and be able to predict where they're needed based on weather and whether it's the weekend or a weekday and all kinds of other stuff. So it's a fun data set. There's an RGB image of Bill Gates if you want to do any kind of facial stuff. That's a lot of fun to play with. There's breast cancer data, book reviews from Amazon, a bunch of CRM data that's fun to play with, the flight delay stuff, German credit card data, so all kinds of stuff. A lot of good stuff in here. So you can do the samples. If you want to play with the samples, you just drag and drop Bill Gates right there, and then you can wire it up and do some fun stuff with that data. So that's one way, use the sample data. Way number 2 is you can also if you want to upload a data set from your local machine, you can do that. And the way you do that, this one is kind of the hardest one to figure out because you would think it'd all be under data input and output, but you would be wrong. You go to new and then hit data set. And then what this does is allow you to upload data set from local. So if I go here and then I browse to, say, the here, emotive, data, so I can grab some data of people telling the truth or lying and get what their EEG looks like and be able to upload that. All right? So this is just a CSV file. And it supports several different file formats. So it does support CSV, it supports TSV, it supports plain text, SVM Lite, this attribute relation file format, R data. Does anybody use R here? Yeah. Anyone use Python? Yeah, all right. All right, so all kinds of good stuff you can do using those right now as well. All right, so that's the next way to do it. So we've seen how to grab sample data. We've seen how to upload local data. The next things are data input and output. So I can import data like this. So this is the way that I would grab data from the somewhere else on the internet. Let me actually just, hold on. Take this zoom down a little bit. Okay, can you guys still see okay? All right, so in this case, what we have with this import data is we can pull the data from various places. So we can pull it from somewhere else in Azure. So from Azure, Azure Tables, Azure Storage, SQL Azure Database, anything right there. You can pull it generically over HTTP. That works. You can run Hive queries if you're doing anything in the big data space and you want to hit a Hadoop or an HBase cluster. Party on, we support that. And then there's a generic OData feed provider as well. So if you're pulling, and then there's a preview feature of pulling stuff from an on-prem SQL database. So not necessarily SQL Azure where it's running in our cloud, but you can pull it from on-prem, establishing a secure connection there as well. So then you just have to fill out just kind of the various information about where we're getting this data from and account keys and stuff to do that. So that's number 3, and then the last way to get data in. Oh, by the way, with the other one, once I submitted or once I hit that new data set, if I was uploading it locally, it would then appear here under my data sets, And then I could pull, for example, manager lie data right here and be able to work with that. All right, so it would all appear right here. That's data of my manager lying to me, right there, and of his EEG while he lied to me. Okay, and then the last thing we can do, the last way, is this enter data manually. So what you can do here is you provide some data format. Let's take CSV, and we could do something like square footage, comma, what was the next thing? Zip code, comma, price. To use that example I used at the beginning, and then I could put in 2,000, 48075, you know, however much money that costs. Quick point in case this isn't apparently clear, don't do this for a full data set, right? So with the amount of data that you need to do machine learning well, you don't want to hand type all your data in. So if you do that, you know, the ones that I actually use all the time are the new data set and then the import data. Those are really the two strong ones. This is really great. This enter data manually is really great when you want to do a quick lookup table. Like when I'm doing flight data stuff and I need to map that BNA actually means Nashville Airport and, you know, LAX is Los Angeles or whatever. If I'm mapping, just doing a quick lookup table, it's good for that, and it's also good for demos when I'm doing a quick demo for someone. Don't use it for realsies, okay? Good. All right, so it's good for those situations. So it's really nice when you just want to have a quick data, blah, 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 and throw stuff in there quickly. So it's nice for that. Okay, so I'm going to go ahead and so you see the 4 ways: sample data, uploading using this new data set to upload local stuff, pulling stuff across the internet using import data, and then enter data manually if you want to do like a lookup table. All right, so I'm going to go ahead and delete all these, and we're going to start from scratch and do some very, very fun Titanic stuff. Now, how many of you guys have heard of Kaggle? Yeah, you guys are smart. I love it. Okay, those of you who haven't, though, you are in for a treat. So Kaggle is awesome. So Kaggle is what they call themselves the home of data science, and they host all kinds of competitions on their website. And if you just want to learn more about machine learning and you want to get better at it, usually the hardest part is, you know, hey, I want to do machine learning. You know, what can I do? You need to find, number 1, a well-defined problem to solve, and number 2, data to solve it with. And what's great about Kaggle is it gives you both of those things. It's awesome. So what they do is they host, you know, all companies come to them and bring their business problems and then give you a really cool problem to solve. Like Yelp had this one problem around people are, Instagramming pictures of restaurants, and we want to map, these things to this restaurant. How do I do that? You could use GPS coordinates and pictures and that kind of thing. So it was just really, really interesting, kind of fun challenges. And as you can see, there are great cash prizes, $100,000 for this ultrasound nerve segmentation problem. So really, really cool website. And I mean, if nothing else, it's a really, really great learning opportunity. If you want to get better at machine learning, just play, and it's a great community. A lot of people share the scripts and the things that they are using. And they share even more after the contest is closed, and they're even more free sharing. So it's really, really cool just to learn and play with. So the data that I'm using here, in case you want to try this later, is this data right here. So it's this Titanic machine learning from disaster data. And there's all kinds of tutorials and stuff I bet you could find on the web about this data set. But they all kind of follow the same format. This competition details, get the data, and make a submission. So for competition details, they tell you, here's the problem we're trying to solve. There was a ship. It's called the Titanic. It sank. The basics, predict who survived and who didn't, and then get the data. And so this is really nice because you can then grab the data. So any of you guys can grab this data later if you'd like, and then it gives you description of everything on there, and so we can jump back to that later if you want. And then you can make a submission on the final thing. Okay, so that's that. So now let's go here and actually try to solve the problem. So I've actually already uploaded the data. I've downloaded that Titanic data set from the Kaggle website. And I am going to, and I uploaded it here. I actually already have it up there, so I won't even bother. So let me just pull it. Yeah, the Titanic training set. Let's use that. And now what I'm going to do next is let's just look at the data. And I'm just going to kind of brain dump all of the things that I'm thinking when I look at this data and how I would go about figuring out what data to throw away, what data to massage a little, all of those kind of things. So I'm going to right click on the output node here and hit visualize on my data. Come on, internet, yeah. All right, so I have here, you can see 891 rows of data in 12 columns. So that's kind of some summary data about this. And then we can go through and kind of look at each of these individually. So first, I'm going to select passenger ID. Now, just by looking at the name of the column, it's an ID, and just looking at 1, 2, 3, 4, 5, I can pretty much guess that this is going to be a randomly assigned integer for each column in the data set. But to confirm that, you can actually go here and look at the statistics, and you can see the minimum value is 1. The maximum value is 891, which is the same number of rows as the data set, and that there are 891 unique values. So that confirms what we were thinking, that this is just a randomly assigned integer. So everything by default that gets sucked into Azure Machine Learning is treated as a feature, meaning this is something that would influence the thing that I want to predict. And so in the case of passenger ID, I don't want that data, right? I don't want that to be used as a feature, because that's going to lead to something like overfitting, where essentially you wouldn't want to build a decision tree that says if the passenger's ID is 17, they're going to die, because it doesn't generalize well, right? To new data. As I get new data, number 1,000 or whatever, it's not going to be able to scale well. So the passenger ID is something I do not want to use as a feature. So what I would do is actually eliminate that as a feature, but this is actually kind of a minor point, but if you do want to participate in the Kaggle challenges, you actually, the format that they want you to give the results in is passenger ID and the prediction, whether they're going to survive or die, as what they want. And so you actually do need to pass through the data without treating it as a feature. So I'll actually show you how to do that, just in case you guys want to play with it later. So I want to keep that data in there, but I don't want to use it in my algorithm. So I'll show you how to do that in a second. All right, the next one is survived. And you can see there's actually two values right here, two unique values, and they are 0 and 1. And survived 1 means that they did survive, and 0 means they tragically perished. And so you can actually look at there's a histogram that they show here. And so you can actually get kind of see that 62% of the people in this data set actually perished, and about 38 people survived. So kind of interesting data to look at the data sometimes. So that's the survived thing. So right now it's treating this as a numeric feature. So this survived is the thing that we want to predict. So we don't want to treat that as a feature, right? We want that to actually be our label. This is the thing that we want to predict. So we're going to have to change that from feature to label. And then the second thing here is we're treating it as numeric. And sometimes there are numbers that you don't actually want to treat as numbers, all right? So imagine, for example, let's go back to that predicting housing prices thing, where I was using zip code as one of the things that I was feeding in. That's a number, right? And so any machine that takes that is going to accept it as a number. However, would it make sense to average zip codes together, or that sort of thing, or do math with them? No. It doesn't. The reason for that is that the zip code, while it's a number, it really isn't representing a number. It's representing Ann Arbor, Michigan, or San Francisco, California, or wherever. And so, yeah, there you go. So it's basically, if you're developers, think about an enumeration, right? When we use an enumeration to represent something different, a category of things. So that's essentially, when we do that, we basically want to make something a categorical variable, is what that's called. So for survived, we're going to make that from numeric, we're going to change it to categorical. So that way it treats it as these two distinct experiences. You survived or you died, all right? And doesn't treat it as a number. Does that make sense? Okay, cool, thank you. All right, the next thing is, so we're going to change that into a categorical label, is what I'd like to do to that. All right, and then the next is passenger class. So you can look here and see that there were some of the first class passengers who were wearing naughty necklaces in their cabins and being all fancy and going to teas. And then there were the second class passengers. And then there were the third class passengers that were doing the Irish dancing in the basement or hull of the ship and all kinds of good stuff. So all of my facts are completely historically accurate based on the movie Titanic. Which I know has absolutely 100% historically accurate. So, yeah. Oh wait, we're gonna get to Rose. So in this case, what I have again is a minimum. I have a minimum, maximum. So 3 distinct values. The minimum is 1, 2. So we can see that they're 1, 2, 3. And so again, this is a feature. Good. I think I do want to leave this in as a feature because I think the category, your first class versus third class passengers, if the movie Titanic is any guide, which we all know it is, the third class passengers were all, let us out, while they were boarding the first class passengers with the bars. Do you guys remember? You're like, you don't really know your target audience very well, Jennifer. Yes, let us out. All right, so that's how it happened. So that's the third class passengers. So I do think, and then they boarded the first class passengers first. So if that's at all true, you probably have a higher probability of survival given a first class ticket. So I think we're going to leave that in there as relevant data. However, I am going to change that from numeric to categorical, because again, it's kind of 3 distinct experiences: a first class, a second class, and a third class experience. Okay? Okay. The next thing is name. And you can see of 891 rows of data, we have 891 unique values for my name. When you see that, in general, it is not a good thing to use to be a feature. It probably is not going to give you much relevant information. In this particular case, for the machine learning purists in the room, maybe I could find some kind of data and look up and try to find like the wealth of various names, like the Vanderbilts would probably be more likely to survive, and maybe there were some lower class names at that time. But for the purposes of a 1-hour demo, we're just going to throw out that data. Okay, does that make sense? Why I would want to do that? Okay, when there's one unique one for each person, it typically doesn't scale well. All right, next thing, gender. So there were male and female. We have about 65% men and about 35% women in this data set. I do think that this is likely a relevant feature, right? Because they tended to board the women and children on the boats first. So if you were female, you probably did have a higher likelihood of survival. So I think we're going to leave that in as a relevant feature. That makes sense. However, string, it's being treated as a string because it is text. Makes sense. Again, this is a case where I don't want to do text analytics on the words male and female, so I don't really need those to be strings. So I'm going to also change those to categorical, meaning you have this male experience or the female experience on the ship. Okay? Okay. The next thing is age. So age is actually a fun one to play with when you have a little more time. So I do think it is a relevant feature. They did board the children on board first, so that's, I think, age may be telling. It's numeric right now, so there's a lot of different things you could do. I'm actually just going to leave it as a numeric feature just as it is, but if you want to go back and play with this later, there's a lot of interesting things you can do, especially around age. So if you look at this data, we actually have kind of maybe 3 unique experiences here. We kind of have the children right here, we have the adults, and then we have like the elderly. And so you could almost see if those match to the survival things, and if it made sense to parse it like that, and then just change it into a categorical variable of you're in one of these 3 categories. The other thing that's interesting here, like when you think about like decision trees and such, a lot of times when you're trying to diagnose, because some of these algorithms are linear and some are nonlinear. And like something like a decision tree can handle nonlinear data. And if you're doing something where you're trying to like predict whether a given illness will kill someone, a lot of times the very young and the very old are very susceptible to a disease, and then kind of the adults are more likely to be okay. And so when you look at cases like that, you just can't represent that by a linear function. So when you're thinking about which algorithms to use, when you have things that are very clearly nonlinear like that, go decision trees or that can handle that. All right. Okay, so that's the age. We're going to leave that as a numeric feature right now, but you could do all kinds of fun stuff if you want to go back and do this yourself. The next 2 are actually around the family units. So this one, the SIB-SP, actually stands for sibling or spouses. So it's the number of siblings or spouses you have on board, and it's a numeric feature. You can see the maximum number is 8. Somebody had 8 siblings or spouses on board. So that's kind of interesting. Yeah, it's kind of interesting in that. So I'm guessing, so just again, basing my, on stupid knowledge that's completely based on the movie and not at all on reality, it seems like the females were more likely to survive, right? But then when you think about the men and what would make a man more or less likely to survive, I'm wondering if he's part of a family unit, right? I mean, looking at just like someone had 8 siblings or spouses, and so I'm assuming that that's siblings, that we have some kids or someone with a big family on board here. And so if it were my family, and me and I had 8 kids or whatever, in that situation, my kids would be jumping overboard at the first sight, because that's how my kids are, and I would very much want my husband or someone else there to help contain the children from leaping overboard with glee, which they probably would. So in that case, maybe men that were the big family were more likely to actually make it on the ship. I don't know, but that might be just something interesting to think about. So, and then same thing here with this parent-child. So you could actually merge them together and be like part of a family unit, yes or no, make it categorical, binary thing, or you can also do some interesting stuff around just kind of putting the family units together and predicting that, okay, if these people were likely to survive, maybe the rest of them were more likely, and some other fun stuff there. But for this, we're just gonna leave them in as simple numeric features. But the parent-children, again, is a very similar thing. Okay, then the next thing is the ticket. So this is a fun one. This is a string feature, and there's a whole bunch of different unique values here. But let's just take a look at some of this data, shall we? The first one is a letter / a number space more numbers. The second one is 2 letters, a space, and a bunch of numbers. The next one is letters / letter number period, and then a bunch of numbers. And then we get to a bunch that are just numbers. So whoever designed this ticketing system, I don't know what they were thinking. This is like, so just having to parse this fills me with rage. So if you are designing a ticketing system anywhere, please don't do this. This is just, this is.
Infallible ticket system.
Oh my God, yeah, exactly. So the ticket thing, so this is just the ticket number, essentially, or the ticket ID that was assigned to you. So for this, I'm guessing it's not actually going to make a lot of difference. So we're just going to throw this out, partially because I don't think it's a relevant feature, and partially because I don't want to have to parse that nonsense. All right? So that's the ticket number. The next is fare. So this is how much the person paid for the ticket. This, I do think, would actually be a lot more relevant, right? Because if you paid a lot of money, you're probably more likely to survive, unfortunately. But looking at this data, again, it's a numeric feature. That makes sense. You can see the minimum amount paid was 0, like that young ruffian Jack Dawson who snuck on board gambling. Oh, my goodness. And then the max value is $512. So people were paying upwards of $500 as well. And here's the really fun thing. There were 248 unique values. 248 different values for people to ride on the Titanic. So kind of like if you ever had to book a flight, let's say to Singapore, for example, and you go and you look at the price, and maybe it's not that bad, and you're like, okay, cool, you know what, I could actually afford this. This fits in my budget. And then you go and you ask your manager, and your manager's okay, and you check with your husband, and you figure out childcare, and you're like, oh, this might actually work, great. And then you go back and you check the same price, and it's like, oh, it saw that you were looking at it, so bam, it just increased the price by an extra $1,000. And you're like, darn it, supply and demand, and really smart algorithms that Delta.com is using. It's nice to know they did that back in the days of the Titanic. This is not a new thing. For 248 unique values to ride on the Titanic. So anyway, I do think that this is a good thing. So we're going to leave this in as a numeric feature. I do think that this might be telling, so we'll leave that one in. The next thing is cabin. So this is whether or not you had a cabin to paint your, or if you were one of the people dancing on the doing your Irish dancing on the bottom. And so this is actually kind of interesting data too. You can see that the majority of people did not have cabins here. There's missing values for 687 different values here. So there's a couple things you can do with this. So just the short thing, just for purposes of time, I'm actually going to throw this data out. But, if you ever want to have fun on a Friday night, here's what you should do. You should go back to this data, and first of all, you could do something like just change it into a binary thing of yes, I have a cabin, or no, I don't. That's one thing that is probably very telling. Another thing you could do is there's actually maps out there of what the Titanic looked like, so you can go in the maps and actually see where the various cabins are and then figure out, okay, for the cabins that are around the edges and that are closer to the lifeboats, those people probably have a higher probability than the people who are like towards the middle and like down a bunch of levels and that sort of thing. So that's really, really fun if you ever want to just totally geek out on maps of the Titanic. It's super fun. But anyway, for this, we're actually just going to throw it out. But there is signal in there. That's not actually noise. It's just lack of time. All right, and then the final thing is the embarked thing. So fun fact, I did not know this, but the Titanic actually had 3 different points of embarkment. Like before it headed off across the Atlantic, it stopped at 3 different places, 3 different ports. So if you go back here and look, you can see the majority of people actually boarded at Southampton. But there were other ports as well. So that's just kind of an interesting thing. And this is something where I'm not sure if it's actually going to be relevant or not, so let's leave it in there and see if there's any correlation that the algorithm finds. So I am going to leave that in as a feature for now. It is a string for right now. I'm actually going to change it to categorical to represent one of these 3 unique things, because again, we don't want to do text analytics. Good? Good. All right. So that was all the stuff that I would want to do to this data. Now let's actually go back and implement all of it here. All right, so I'm going to start by doing some data transformation. So I'm going to go here and do my project columns, which is the select columns and data set. So let's first of all throw out the data that I said I wanted to throw out. So I'm going to go here, launch this column selector. I want to leave the passenger ID. I said I would leave that in, but I just want to clear it as a feature. We need survived. We need the class. We're going to throw out the name. We're going to keep gender, age. We're going to keep this, the family stuff. We're going to throw out the ticket price because it was horribly parsed. Fare we're going to keep. Actually, cabin we're going to throw out. And then embarked we're going to keep. So I'm going to pull all of those through and then throw out the name, the ticket, and the cabin for right now. So that's the first thing I wanted to do. So that will just only carry through some things. Then the next thing we're going to do is here in manipulation again, I'm going to edit some of the metadata here. So there were some things I wanted to make categorical and things like that. So let me go through here and just do some of those things. So the first thing I wanted to do is the passenger ID. So first of all, you can start with all columns or start with no columns. I'm going to start with nothing and then just add the ones I want, since I'm not going to choose that many of them. So let me do just the passenger ID. And that was the thing that we wanted to pass through and not actually have be a feature, because everything is a feature by default. So what I'm going to do here, and you can do lots of other stuff here, you can actually change the data type, which is great. Like if you have like a date and you'd want to change it into an integer or something to make it easier to do math with it. And then making things categorical is right here. You can actually change the column name like this as well. I'm going to change this from a feature to clearing the feature. So now it will be passed through, but it won't be treated as a feature. Okay? And now I want to do some other things. So I'm going to have to grab, but I want to do it on different columns. So I need to grab a new edit metadata to do that. And the next thing I want to do is let's make that survived. Let's make that a label instead of a feature. So I'll go in here, change that to be a label so that we know this is the thing that I want to predict. The next thing I wanted to do is there was a bunch of stuff I wanted to make categorical, right? So let's go in here and take a bunch of stuff and make it categorical and go through and select some of these things. So what did we want to make categorical? We wanted, that we're not going to use. Survived should be categorical. The class of passenger should be, we threw out this. Gender should be categorical. Age, no. Leave that a number, leave that a number, leave that a number. That's gone. That should be a number. And then I think this should be categorical. The embarkment point as well. All right? So now we have those things, and we're making them categorical. And then, is there anything else? We got rid of the thing. We did the, is there anything I'm forgetting? I don't know. Let's test. Let me just go ahead, and I'm going to run this for a second. And I should mention, Azure Machine Learning, the whole time I've been building and stuff, it doesn't charge for any of that. It actually just charges when you when you do this. So the time that it spends running is when it actually charges. So that, whatever, second or two is when it actually charges you. So if I go here and I right-click and hit visualize, let me make sure everything is as it should be. All right, so we're down from 12 columns to 9, which is good. Passenger ID is a numeric, and it's not a feature anymore. Good. This should be a categorical label. Good. Passenger class is a categorical feature. Good. This is a categorical feature. Good. Numeric feature. Good. 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 The fare is a numeric feature. Good. And then the embarkment point is a categorical. Perfect. Okay, so everything is going according to plan. So now what I want to do next is let's actually do the fun machine learning stuff. And we'll start by actually splitting my data. As I kind of talked about before, we're going to split, and you can split a couple of different ways here. One way that you can split by like regular expressions or other things too. I'm just going to do a random split between them. And I want this parameter is asking for here is the fraction of rows that you want to come out of the first output node here. And I'm going to do a 70-30 split. So let me hit 0.7 here. So 70% of the data will come here, which will leave 30% coming out there. And then you can set the random seed if you want. And then if you want an equal number of people, like percentages equal, whether they like survived and died, if you want those split equally, you can actually set a stratified split there as well. I'm just going to do it all random for right now. All right, so now we have that. Now let's build some fun models. So I'm going to go here to train some models, which is under here. This is too much stuff. It's under train. So I'm going to train 2 models. I'm actually just going to build 2 at the same time, and then we'll see which one we want to use. So I'm going to take that 70% of the data and pull that into the train model to train it. And you can see as I grab it, one of the little nodes turns red and the other one turns green. That just gives you data type correlation. So you know that since this is green, this is something that's a valid data type to go there versus whether something is not. So I'm going to take the 70%, use that to train my models. And then I need to put 2 different algorithms in here as well. So let's go to the initialize algorithm. And did we want to use anomaly detection, classification, clustering, or regression? Very good. This is a classification problem. All right, so we're doing 2-class classification. So let's start using, I usually start by doing 1 linear and 1 nonlinear algorithm just to see which one performs better. So let's do a linear one, like maybe the logistic regression is linear. We can do that. And then one of the decision ensembles. So let's do a decision jungle and stick that right there, bam. Okay, and then so I have algorithms wired up, and all of the parameters that you can use are right here as well, so you can set different parameters. And then if you have no idea how to set these, one really cool thing you can do is that there's this, this module that was formerly called sweep parameters. It's now called tune model hyperparameters, and you can pass that in, and it will basically pass a range into here. So that way you can build, it'll generate a lot of models and then find the one you can tell it to optimize, for example, to accuracy. And then it will give you the most accurate model as your output. So that's a neat trick if you don't understand kind of what all of those things mean. Okay, so that's the 2 things I'm going to build here. And then let's score my models. So I'm going to go down here to scoring. And I want to score 2 models, so 1 and 2. And then for these things, I just have to tell it what my label column is. So I'm going to say survived is the label column here, and survived is the label column here. So it knows what it is it's trying to predict here when I build this model. And then I'm going to take this trained model, pass it in, and then I'm also going to pass in that 30% of the data that I held back to score my model to see how well it performs. And then I'm going to do the same thing over here. The trained model goes here. The 30% held back goes here. And then we have our things. We're pretty good. So then the last thing I want to do is let me just evaluate and see which one performed better. So evaluate will give me some really nice data and visualizations of which one is performing better, so I can get a good sense for that. All right, so I'll go ahead, save that, and run. And that should take just a second. It's actually really, really fast, but just to get us in the mood. Never let go, Jack. Never let go. Oh, it's done already. Darn it. Azure Machine Learning, why are you so efficient?
Who designed it anyways?
Who designed Azure Machine Learning? Yeah. Okay, so I'm going to right-click on this evaluate model and hit visualize. And then we shall see a whole bunch of graphy goodness. So what I have right here is, so first of all, this is kind of hard to understand, but there's a kind of a blue and a red one. The blue one is whatever came from your left-hand side, and the red one, the second one, is whatever came from your right-hand side. That could be explained a little bit about it. But so what this tells me here, so this was the linear regression here, so that's the blue one, and it looks like it's actually running a little bit lower. So let me explain what this graph means. This is the true positive rate here, and this is the false positive rate. True positives are good, false positives are bad. So you want false positives to actually be pretty close to 0, and then you want true positives to be close to 1. So perfection would be this graph going like that. That's awesome. Then right here, this is like essentially 50-50 random chance, a monkey flipping a coin, right? So you want your algorithm to do better than that. All right, if you're not doing better than that, then start over. There's a problem. But what you can do, what I can see then is just from looking at this, it looks like my second one, the decision jungle, is actually doing a little better than this one. But we can verify that by, let me select my blue right here and then go down here. And it gives me a whole bunch of great data here. And you can see here the accuracy is about 79%. And then if I choose this one and look, the accuracy is about 81%. Cool. So just thinking about that for a second, in maybe 45 minutes or however long that took, and it's actually a lot shorter when I'm not explaining everything and playing random YouTube videos and such, I built something with like 80% accuracy. So that's pretty cool, right? Imagine if you could predict whether your customers were going to click on an ad 80% of the time. Pretty powerful stuff. So it's really, really cool to kind of think about scenarios in your own businesses, like how would this prediction help us? And I didn't even tune the model. I used all the default parameters for each algorithm and that sort of thing. So there's a lot of stuff you can do to optimize this even further. Okay, so what we get here, some of the data, if we look at this, we get our true positives and our true negatives. We want those to be high. Our false positives and our false negatives, we want those to be low. And then we get accuracy number, and then also a lot of things that tell us like how well it'll like scale and generalize to new data, things like precision, recall, and then F1 is actually a combination of recall and precision. And then we get the overall area under the curve, which is about 85%, which is pretty good. And then you actually get binning too, so you can see how that breaks down, which is kind of cool. All right, so let's say I'm just for the interest of time, let's just pretend that we like our decision. I would actually go back here and I would tweak parameters and make things even better and that sort of thing until I was happy with my accuracy number. And then what I would do eventually, when I was all good, is I would select the model that I like. So let me select the decision tree since it was doing just a little better. And then I would go here and set up a web service. So there's two different web services you can do. A predictive web service is something that I can call with Titanic data. So here's some demographic information about a person, and then it'll give me back whether they survived or died. You can also do a retraining web service. This is great if you want to rebuild your model periodically. So I can retrain it by sending in fresh data, and then it rebuilds the model based on that data, and then I have a new model. All right, so you can do both of those things programmatically. So for this, I'm just going to do a predictive thing so we can actually see how you would call it. And so, oh, watch this, don't miss it, don't blink. Ooh. Whoa. Ah, somebody worked really hard on that, you guys. There was I know, it makes me laugh too. So there's what that cool animation just showed you is some things. Let me actually zoom in so you can actually read what this does. But if I zoom in here, you can see that what it did to my model to make it a predictive experiment is it added this web service input node to the beginning. So this will allow you to have an endpoint to be able to take data. And then it grayed out this Titanic training set. The reason it did that is because it's not using any of the data in it anymore, but it is keeping the metadata, so I know what the different columns are and the data types of each column. So it's using that, but not the actual data. So that's why it shows it here still grayed out. Then it actually it kept all of my data cleaning. So select the columns in data set, all the metadata editing, it's doing all that same data cleaning. All my data cleaning stuff was left in. But then all of that splitting the data and testing the two different ones and comparing to see how well, it threw out all of that stuff because I don't need it anymore. And it just took that trained model that I built that I was happy with, and it created it here and stored it off as its own little trained model based on whatever title I gave it right here. And then it calls it into a score model, and then it just returns all the data. And by default, it will return back all of the data that you sent in plus 2 more columns, which are the prediction and then a confidence level, okay? So you get those back, but you can stick another select columns in data set, just like we did at the beginning right here. If you don't want to return all of that stuff, you can just filter it down to just the stuff you want to return by just sticking one of those in here and then passing that to the output. All right, so now it is, we have this predictive experiment. You actually do have to run it once just to make sure that everything flows and that little animation did everything right and didn't mess anything up. So you give that a quick run. And this one is usually so fast, it's not worth it to slip over to the song, but it might be. Why not?
Every night in my dreams,
Oh, Celine. Oh, it's done. Darn it.
I feel
Oh, the mean husband. Okay. So now what I do is I can deploy my web service. So I'm going to deploy this bad boy out. And so what it's doing for me now is this beautiful, just sticking it out, exposing a REST endpoint. I can hit it, and it generates an API key. So only people who have this API key can call it. So you guys are all welcome to call my Titanic service if you want. I'm not going to hide that. And then there's actually 2 different ways you can call, and this is kind of neat. There's a request response. If you just want to send demographic information about a single passenger and get the response back, you can do it that way. Or there's batch execution. If you want to send up a whole CSV of information, have it process all of them and get all of those responses back, you can do it that way. And let me just show you for a second the documentation here, because if you click on either one of these things, you get the most beautiful documentation auto-generated for you that I absolutely love. So if you look at this, they give you, here are all the exact requests that you need to call. So it gives you, here's the exact URL that you need to call. Here's what your header should look like. Here's a sample request for you and using data from your things. And then here's the response. Here's the status codes that could be response. Here's the response headers. Here's a sample one for you so you can see exactly what it would look like. Again, using data from my real scenario. Then there's input parameters. So it gives me all the input parameters, passenger ID. It gives you their data types, all of that good stuff. And then output parameters as well, where it gives me all of those things, the type, and it extrapolated from my data for what the allowed values are. So if I wanted to if I just built this and I want other developers on my team to be able to call it, I can just basically not even have to talk to them, just say, here, look at that, code to that, bam, done. It's really nice, right? I think they did a really good job. I was impressed with this. I did not build this. Somebody else did this, and I think they did a good job with it. So this is your categorically, it tells you exactly what the types are, what the allowed values are, all of that goodness. And at the bottom, it actually gives you sample code in 3 different languages. So C# is support. If you are a .NET programmer or a Microsoft developer, you can actually just take this code, copy and paste it into a Visual Studio Console app, hit run, NuGet packages come down, bam, it just works. It's beautiful. And then my Python folks in the house, woo, here's the Python code. R folks in the house, woo, here's the same thing in R. Anyone else in the house who knows how to develop, every single thing has a REST library, and you go to town, there's all the requests and responses, and you should be good, right? Right, not that hard. So yay! So that's that. And then let me jump back here for 1 second to show you one last thing. You can do that, and I can actually call a test on the request response as well. So we can do that. And then the other thing that's really cool here are the Excel workbooks. So this is great for people on your team who are not developers. So let's say I work with business analysts, and my business analysts are not coders, but what you do is you give them this workbook, and what it has is the columns that you need to call, and so they just type in data in the columns, and then it'll automatically call on the back end using macros. It calls out to your web service, the API key is already embedded, all that good stuff, and then they'll get the responses, and they will just show up there in the Excel workbook. So it's really, really cool for business analysts as well. And then let me show you a quick test right here, just so we can make sure it works. Okay, so passenger ID. So the highest passenger ID was 891, so let's do passenger 1000. Survived, we don't know yet, so let's actually just delete that out. The class of passenger, let's say a first class passenger, and let's say her name was Rose, and I forget her last name. Her sex was female. Her age, how old do you think she was? 21, 20, 19? I don't really know. Not 100. 20. I'm going to go with 21, but I'm not really sure there. Siblings or spouses. 0. She did not have a spouse yet, although she was messing around. Like she was engaged. She should not have been behaving as she was. But she did not technically have a spouse yet. So, okay. Parents or children. She had the mean mother, right? The mean mother that wanted her to marry the rich guy for his money, right? Right? Okay. Again, completely historically accurate, you guys. Ticket number, I can essentially just bang on the keyboard, and that would be a valid ticket number based on this system. Fare, so the maximum fare was $512. They were pretty well-to-do, so I'm guessing she paid at least $350, $400, right? You guys think? You guys okay with 400? Let's go with 400. Cabin, we do know she had a cabin. Let's put her in C90. There we go. It just shows random things. And embarkment point, I don't really know, but I'm going to choose Southampton because that was the most common one. So we'll do that and then hit OK. OK, cool. And then it calls the web service and comes back. And I get all of the data that I passed in, again, as I said, returned back. And then my final 2 things are the predictions. It predicts that 1, yes, she would survive the Titanic with a 98% accuracy. A first-class female passenger, obviously, is probably going to do okay. We could do it the opposite way with Jack. That one's probably a little bit more interesting. But how am I doing on time? If I do that, I don't. As much as oh God, don't say that because I will keep talking forever. If you guys give me that, should we try Jack? Do you guys want to try Jack and see how he does? Okay, let's try Jack. Okay, so passenger 2000, or I'm gonna do 1001. Survived, we don't know. Class was 3rd class of passenger. Name was Jack Dawson. I do know his last name. Male. He looks like a total baby face in that movie. I have no idea how old he was. He looks like 12, but 22. Okay, we'll say he's a little bit older than her. Yeah. Yeah. Was he younger than that? Really? I honestly don't know. So we'll go with 22. Siblings or spouses was 0, right? Parents or child was 0. He was all alone in the world. Ticket number, whatever. Fare, he did technically play 0, right? Because he gambled his way on the ship. He won it in a card game. He won his ticket. Cabin is going to leave blank because he did not have a cabin. And then embarkment point, let's go with Southampton again because, again, it's the most common. All right, let's see. I actually don't know what this is going to say. It predict that he is going to die. Survived. And it's a lower accuracy, but it did predict that he died. Ta-da! Should we go back to the music? Yeah. Oh, yeah.
And who could predict her throwing the diamond off at the end?
Oh, my gosh. That is a little crazy, throwing diamonds into the water. That is true. All right, so just a quick thing. If this was a very quick, me talking as fast as I could to explain this to you, but I hope you learned a little bit about, machine learning and Azure machine learning specifically in some of the really cool things you can do with it. It's really nice, like if you don't have a data science background, it kind of gives you enough that you can do some basic predictions and things like that, fairly easily. It gives you the algorithm cheat sheet and some other things to help, get you started and ramp on that learning curve. If you have a data science background, it's awesome. It's like a neat, rapid application development where you can switch in and out algorithms and try different parameters and things like that. So it can be really a really neat tool there. So. Any other questions? Thank you so much for having me. Any other questions? I do have a blog and Twitter and a bunch of webcasts on this. Oh, I do have, too, if there's other people who are interested in doing this, I have a similar talk. It's not quite as cool because it was online, so I couldn't use Celine Dion. But I do have something. If you go to aka.ms, whack, I think Gen Titanic, there's a similar version of this talk that's a little shorter version. Online there, aka.ms, whack Gen Titanic. So feel free to tell your friends. Thank you guys so much. Any questions? Yo, catch ball. Catch ball. Okay, I'm not a good thrower, so we'll. All right, here we go. Ooh, yes.
Okay, something I'm always curious about is when you're using something as a cloud service, how do you avoid breaking the bank when you're doing your training or you've got a web service out there that's really getting hit?
Yeah, great question. So the question was, how do you avoid breaking the bank if you're doing stuff in the cloud? So there is a calculator. So anytime you can see how much money you're spending, and it's all kind of listed very clearly. Here's where the charges are. So it only charges to so the whole time I was building stuff, it doesn't charge for that. When I was dragging and dropping things and looking at my data and all of that fun stuff, it doesn't charge for any of that. The only time it actually charges is when I click that run and it runs stuff through. Now, this was obviously a very, very simple experiment. In more complicated things, it's going to take longer, but you can hit cancel at any time. If something's been running for longer than you think it should be, you can hit cancel and then stop it if you're concerned about that. But it does give you, there's a dashboard in Azure where you can see at any point how much money you're spending and that sort of thing. I play around with, just in demos alone, I think on my demo account, I think I spend, it's less than 100 a month. It's way less than 100 a month. What's that? So you definitely can for like MSDN accounts and BizSpark and that sort of thing, because you get a certain amount for free and then over that you're charged, so you can set the spending limit there. I don't know if I think you could, because I think there's one of the, so I need to, I'm instructed not, licensing is a black art where there's all kinds of crazy things. So I'm not supposed to talk about, like you should talk to a salesperson and they'll give you best stuff. But I think there is a way, because you can like buy stuff up front, like buy a certain amount of Azure credits up front and then spend up to that limit. And you actually get discounts, I think, for buying like bulk up front and then doing that. So yes, but let me get you to a salesperson because they can answer all of those, the sales, the licensing side of it better than I can. I do mostly the tech side, sorry. But yeah, are you sales? Can you answer that or no? No? Okay, let's yeah. Let me get you to the right person. Feel free to ping me an email and I can follow that up. Yeah. Okay, what other questions do I have? Yes, sir.
Real quick, along those lines, are there any tools for like estimation or strategies for estimation that you can use on your data sets?
So estimating what specifically?
The cost that you're...
Cost, yes, thank you. Gosh, I should slip you a 20. So there is the Azure, hold on. You can all search for it on your favorite search engine, Bing. The Azure, I think it's the Azure pricing calculator. Yeah, but there's an Azure pricing calculator that gives you, basically you just put in what you're gonna spend and across services. So like if you're doing, any of our big data stuff, because we have like Hadoop running on Azure and you can just put in everything that you want to spend, storage, how much in storage, how much in this, and like approximately like how many gigabytes, and you can just kind of map out everything, and then it'll spit you out a number. And I think it even tells you like the best ways to pay for it too. But no, there is a great resource for that. So you should find it right here, pricing calculator. So bam. Yep. Yay. Any other questions? Yes, sir.
So questions kind of similar along the line. I want to know bang for my buck. I am the CEO, and I want to figure out, is this worth going with Azure?
Yeah.
I'm a data scientist guy who knows all about hidden layers, Kolmogorov theorem. I can use free software to do it right. I have a bunch of sales guys, and it doesn't give me any clue. How do you decide how many hidden layers you have, what nodes you have, what you're going to do? If somebody knows already which ones you can use as a feature or not, I don't need Azure, the way I look at it.
Okay.
So explain.
Yeah, sure. So the question, as I understand it, is what are the benefits to using Azure specifically for machine learning? Because there's lots of other tools you can use for machine learning. So let me divide that up into two parts. The value you get from using something like Microsoft or whoever. Let's just say using one of the major cloud providers, be that Microsoft or IBM Watson or Google or Amazon, whoever. The benefits of doing that are, first of all, if anything goes down, it's our butts on the line and us who are up at 3 in the morning fixing it and not you. So there's some benefit to me to that. So if something goes down, you call, and then we financially back our SLA. We have financially backed SLAs. So if we go down on you, then we give you money back, like for the downtime. Like we will actually give you money back, and a lot of the other cloud providers don't do that. So that's one thing, is someone else's butt is on the line for when bad things happen. A second thing about just this is global scale, right? So you may start as a startup where, okay, my customers are all in this area and you can all just hit my own server that's running under my desk. But if you eventually want to go, really big, Azure has data centers all over the world, so you can easily get that global scale. You can run in Asia and Europe and all over the place and be able to scale effectively. And then be able to scale out the number of people that are hitting you too. As your business grows, that's the great thing about cloud computing, right? You're getting a lot of business, great, you can turn the dial up and be able to accommodate that. And then if your business is maybe cyclical in nature and you're getting less business, great, I can turn the dial down, but then I'm paying less, yay, everybody wins. So it's this, that's some of the advantages of just using a major corporation as well. And then the second part of that would be, okay, so why Microsoft as opposed to Amazon or Google or IBM or anything like that. So I work for Microsoft, so take this all with a grain of salt and do your research and all that stuff. But from the research I've done, just fact-based, I think we're a good bet. Amazon, I think, is a leader in the cloud space in most other areas, but not for machine learning. Their machine learning offering just came out recently, and they only have one algorithm, as I understand, in there, and we have 25. And I think it's a linear algorithm too, and there's just some data sets that aren't linear. So I think I don't see that being effective yet. Google and IBM are doing some brilliant things in the space of machine learning. Google's AlphaGo, game changer. Like, that was amazing. And IBM, and their self-driving cars and stuff too, that obviously uses a lot of machine learning and artificial intelligence type things. And then IBM as well, IBM Watson, the stuff that they've done, like even the challenging the Jeopardy thing was like really cool. So they're doing really great, big, amazing things in the space. But I don't think I think Microsoft is really a leader when it comes to passing that on to developers, right? Like, I don't see Microsoft, Google isn't giving you the SDK for how do you go and build this yourself. They have TensorFlow, which is awesome. We have a similar thing, the CNTK, which is our deep learning toolkit as well, which is also open sourced on GitHub. And then we have, the cognitive services, which are all of these great things around facial detection and emotion recognition and all this other stuff, that are there for developers. We have the Azure Machine Learning if you want to build your own models. We have just a kind of a wide variety of machine learning offerings. So, and a lot of this is all like stuff that's based on work that Microsoft Research has done and algorithms that they've developed over time and that they're giving, letting people use. So, I think it's a good thing. And from what I've heard from people I've worked with who are using other things, they said that our value is good. We're cheaper than some of the competitors.
The key point I'm making is it doesn't seem to reflect any hidden intricacies of data modeling, because there's a lot more in the hidden layers and all.
Okay. Yeah. All right.
I don't see.
Yeah. So.
I don't see that. It's not.
Okay, sure. So let me point that. So I'm sorry, I misunderstood the question. So all right. So if I'm understanding the question correctly, it is this looks too simple. I'm a data scientist and I need more interesting stuff.
When you say
Yeah.
nonlinear, it's a very complicated thing. And
Oh, absolutely. Okay. Let me.
demonstrated, how does it choose?
Yeah.
Layers or five?
Yeah. Great point. All right. So let me do a couple things. So first of all, let me also say that for any code that you're doing, that's obviously not something good. Let me do Python instead. So there's the ability to drag and drop a Python or an R script into any of this. So you can write your own custom, or take your own custom code that you're already doing in R or Python or whatever, drag and drop it into here, and then be able to run your own R and Python script. So there's the ability to insert your own custom stuff in here as one option. The other thing is, this was a very simple demo because it was an intro to Azure Machine Learning. There are more complicated things that you can do with this that I obviously didn't show today, just partly in the interest of time and partly because a lot of people are new to machine learning. If there's specific things that you're looking to do, some of them may be supported in there, so let's have a chat afterwards because there are some more advanced things supported within here that I didn't get a chance to demo. And then it is a V1 product as well, so it can't do everything. It's not great for visualizing your data. I still use other tools usually to visualize, and then once I get in here, I showed you the stuff for visualization, so you can see the histograms and the data thing and some of that, but a lot of generating graphs and stuff, I still use other tools for that as well. So it's not everything, but let me know what specifically you need, and I'll let you know if it can do it. But yeah, great point. Who has the box?
Okay,
Yes, sir.
so,
Hi.
Couple questions. First,
Sure.
the most important one is, can we punch Celine Dion into your web service and see if she dies? I mean, survives.
That is a great question.
But of less importance is, can this handle more than just text? So can we pass video, photos, or audio into it?
Yeah, good question. So, so the way it's typically done is, I would so yes is the short answer, because we've taken like images and stuff and done imaging processing with this, but typically it's not passed in directly. You usually pass in a link to the thing, and then you suck the thing in from somewhere else. So I would pass in like a pointer to my video or whatever, and then I would pull it in that way. So yes, that is possible.
Okay.
Yes.
Well, the demo was good. One question around this is there a list of, I mean, since you're referring to the product details that is available, is there a list of what kind of
Yeah. There is. So there is, so let me see if I can find it. So Azure Machine Learning Module List. So there's a reference. Yep. So here's a list of all the modules that are available. So if you Bing Azure Machine Learning Module List, it should come up as the first thing. Another thing that's cool as well, if you just want to get a sense for the roadmap of the product and stuff, here's a fun little sneaky trick you can use. Go to that HackML blog post that I mentioned before. So aka.ms/WAC HackML, which will take you to my blog, and then scroll down, and all the, read it first because it's awesome. But then after you do that, go to at the very bottom, there's a link to feature requests for Azure Machine Learning. If you click on feature requests for Azure Machine Learning, you can see here's the stuff that people want. And so if there's stuff that is in here that you want as well, go in there and upvote it. And then tweet that you want other people to upvote it. And then, because it's the customer voices that really make the most difference. And so when people say, okay, we really, really want F# support, like I can go and tell my team, we really, really want F#, and they're like, okay, Jen, that's fine. And then a customer says it, and they're like, oh, you guys want F#, and they're like, yes. I'm like, oh, okay. So it really does make an impact. And when you look at the things that are rising to the top, these are the things that get considered for the next thing. And it's also nice because you can see what's coming, because they also mark some things as in development. So you can say, oh, cool, they're working on that one right now. Awesome. So this is a good way to kind of get a sneak peek at the roadmap, what people are building right now and what people want. So and just make sure that it doesn't already exist before you add a new thing in there. Make sure it doesn't exist first and upvote it if it already exists, just to give it more power to that. Yeah, yep, so the list of algorithms is all under initial thing. So they're all listed in the algorithm cheat sheet, so you can get them from there. Or there is, if you go to no, I do not want to participate, thank you. If you go here to, you guys should all participate though. If you go here under machine learning modules, yeah, and then you go under initialize model, all of the algorithms are listed under here. So these are the 4 categories, but then once you expand them, like classification, for example, it gives you all of the classification things. So you can just go here under the, here, I can, oh, it doesn't do that, but I can help you find it. If you can't figure out how to navigate back to that, just shoot me an email and I will write out step by step how to do it. But that's how you do it. Or watch this recording of how I just did it. Yep. Any other questions? Who's got the box? Yes.
Great job. As a newbie in the whole machine learning landscape, one of the questions I had is there ongoing retraining? So you put in the data model. So what happens? So for the next 2 months, my analyst is using this, and the ticket prices have gone up. Instead of 500 as a top, now they're $1,200 or whatever. Do I need to retrain, or is it going to?
Yes. Great question. 10 points to Gryffindor. Okay. So yes, you're making a really, really valid point. You have to think and be cognizant of what data you're using and what model you've used to make sure that you're making the best predictions. Because oftentimes you might find something like, the data for September 2016 might accurately predict the data for October 2016. But if I'm like a retail store, maybe November doesn't predict December. Maybe December of the previous year would better predict because that's a good sense of my holiday season or whatever. So the way you can do that is you go to set up web service and then hit the retraining web service. And what that will do is set up an endpoint so you can hit it programmatically. So if you wanted to update it, it's up to you how often you want to hit it. But if you wanted to update it once a week, you could call that once a week with fresh data, and then it would rebuild the model once a week. You could also hit it once a day. You could hit it once a month. You can kind of choose what makes sense for your business data.
Yeah, because, well, and over time, it could totally, completely change the whole thing without a whole new data refresh. I mean, because it's still using the historical data. Does that make sense?
Yeah, so it'll only take the data that you pass in.
Okay.
So you can choose to throw out old data if it's no longer relevant and just pass in the new data as well. But no, you make a great point. And it's true. I mean, garbage in, garbage out. It is, it's not magic. It's going to learn based on predictive things. It's really interesting, actually, just thinking through some of the ramifications of that, too. I know, like, in Chicago and stuff, they've done some work around predictive policing. And so they're taking all this historical data of what they've done and then using that to make predictions. And it's like, okay, if there was bias in your historical data of these are the people that we were arresting or these are the people that we were then that's going to continue to perpetuate. And you don't want to automate racism, for example. So you have to really think about some of the ethics of machine learning and ethics of AI and such. But great point, sir. Yes?
Two questions. One about training. So if you keep retraining, is there a way to measure how well the retraining is going and maybe like build a new model if something happens?
Yeah.
And then once you're done training it, what's the next step to make it into production?
Yeah, so once you hit the retraining, you can, from there, so there's actually a whole blog post on this. I think it's actually right on that HackML, but yes, there's if I go here back to the HackML, that's step, I think step 9 or something for how to win a hackathon. Right here, there's a great thing that goes through all of that. It's step 9, retrain your model over time. So this article goes through how to retrain the models programmatically, how to reset all of that, how to get the new things. So go to aka.ms/hackml, step 9, click on this, and this tells you how to do it.
Awesome.
Yeah, no problem. Any other questions?
Time for one more?
Time for one more? Okay.
Last one.
Yes, sir.
So one of the advantages of having sort of a graph workflow representation of the stream, and particularly being in sort of a scalable cloud environment, is having the capacity to cache or memoize particular computationally intensive or time-intensive aspects.
Yes.
Does it currently implement anything? So like if you have a cascade or a multi-stage model and you want to retrain it and the data has only changed in a particular way, is there intelligent caching so that you're getting more bang for your buck and also converging faster?
Great question, and yes, and I'm glad that's the answer because otherwise it would seem really bad. But yes, so the question he asked is, does it cache? And so I don't know, you probably didn't see it because I was probably switching over to Celine Dion. But if you saw the second time I ran that model after it had already done the data flow like halfway through, it actually just goes green arrow, green arrow, green arrow. It just boom, it caches all of that stuff because I only changed stuff that was after it in the model. And so it does intelligently cache anything that hasn't changed. If I made changes back up there, it would rerun it. But since I hadn't changed anything right there, no dirty bit, and it just continued to go, just run the thing. So it is smart about how it spends your money. The one thing I will say is that one of the things that's on the list of things to add is to just run selected steps. We don't have that functionality yet, but I want it badly. So I think it's in the works, but you can go in and upvote it if you want. But just to be able to say, okay, I want you to just rerun this, this, and this, and then right, exactly. And you can do that by like removing and doing stupid tricks. But I want that just to say bang, 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 just run those. And that's not quite there yet, but it's coming. If I get my way, I do. All right.
Well, let's take a big round of applause for our speaker. Thank you, Jennifer. Well, thank you so much. So Jennifer's contact is here. So again, if you haven't taken a picture, please do, and follow her on Twitter. Again, we are convening Duo Tech Talks here every month. We don't have the next month's Tech Talk up yet, but if you're on the Meetup site or you're subscribed, you'll see and hear. And thank you for all coming out. Drink our beer, eat our pizza, and see you next time.